Okay, so there's only a couple of coding questions that they will ask on EQAO. One of them is if else. Okay, if savings equals 0, then say this. Else, it will say your new savings total is this much. Okay, another one that they would use is repeat. Okay, if they have a question that they want you to ask 4 different times, they can use the function repeat, and then it will ask you the same question. What was your score? And then add it to the total. What is your score again? And then add it to the total. What is your score? What is your score? After 4 times, that your total score, which is your variable, will have the total of all 4 answers. Okay. And so if else, repeat, anything else. Okay, so remember these are like setting this stuff right here. These are just variables. Okay, so at the beginning, instead of saying like let X represent number of goals or something like that, you just let X equal 0, give it a number, and then every time you have something, you just add it on, assign a new value to it. But this is just for setting variables. Okay. And then, yeah. So you can see like the purpose of this coding homework, it was not to get you to actually code on computer with using Scratch, using Python, because if you type in these commands in there, you're never gonna get a program to run. So you can see why you're learning this in math instead of computer science class is we're just teaching you the logic behind it. And deficit means expense minus income, okay, which is what we learned about last class with finance. Okay. Any questions about the coding stuff? Okay, so again, if you didn't do the homework, make sure you at least go through some of these answers so that you're not surprised when it comes to EQAO. Okay, mean, median, mode, and box plot. So mean, what's another word for mean? Average, not not bad. Okay, mean means the same thing as average. So as you guys know, to calculate the average, you add up your data and then divide it by the number of data. So in this case, I have 5 people's height right here. So when I add their height up, because there's 5 people, I divide it by 5. So their average height is 153 centimeters. Okay, your average should always be between the lowest and the highest. Okay, it should never be outside of this range. Median, median. Good job. Another word for median, middle. Okay, so does that mean the median in this case is the 140? That's the middle person. Isn't that what you guys just said? It has to be ascending, right? So you have to tell them to line up in order. Okay, so put them in order from smallest to biggest, and then median is this middle person right here. Okay. What if there is 6 people? So like, let's say, for example, I add another giant right here. Okay, then where is my median? Yep. Right. So then your median, if there's a middle number, so if there's an even number of people, then your median would be in between the third and the fourth one, because there's 6 people here. So how to find the middle between these two? You add these two and divide it by 2. So the average. Okay. In this case, it's also 155. So no matter how big of a giant I add here, your median will still be 155 because these two are 155, right? So in that case, which one do you think is a better representation? If I add in a giant in here and the median is still 155, which would be a better representation, average or median? Average. Yeah. Okay. What about mode? What's another word for mode? Most. I tried to find like that easiest word for you guys to remember. So mode means most. Okay. So out of these 5 heights, which number occurred the most? 155. Yeah. Okay. So if you don't like the word mean, median, and mode, then think average, middle, most. Okay. Okay. And so why do we use mode? So for example, mode is used when exploring average of data that cannot or should not be combined, such as the color of people's eyes in a large setting, or the number of bedrooms in a home in a certain area. So for these cases, you can't really do average, right? So that's why mode would make more sense in this case. Okay. So why does sometimes teacher do mean and why do sometimes teacher do median for like a test? So usually on tests we do average. Like I tell you guys usually the mean, okay, for a test. But how come sometimes I tell you guys median instead? Sorry? Okay, why is it higher though? Why is the median usually higher than the mean? Like, well, let's say we're talking about a math test. You guys just had a math test? Huh? Okay, like so. Let's say we just had a math test, and like the average is 80%, but the median is actually 90%. How is that possible? Yep. Good. All right. Your average will get pulled down if, let's say, some people were sick and they weren't here, they didn't write it, they got 0. So that will really pull down your average. But if you have those zeros, but at the same time you have a bunch of 100% people, then your median could be much higher. Okay, so when you have a lot of zeros or hundreds, it would really change your average. Okay. Okay, so let's try the first example. Example 1. Given the following table, find the mean, median, and mode. Okay, so let's try to do this together. So for the mean, what am I doing again? Add them all up and divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All of them, 13. Yeah, and Nunavut is it's a province itself or territory. Okay, so 15 plus 1195 plus 1275 plus. Somebody do this on a calculator. $15.20 plus $15.20 plus 1175. Okay, somebody do this on a calculator, please. Okay. Yusuf, you don't look like you're using that as a calculator. Oh. Okay, Petro, is that what you got? Good. Thank you. And remember, your average should be in the range of your lowest to your highest. Okay, so it should be somewhere in in between. Okay, good job. Thank you. Median. Okay, I'm showing every step for this one because it's our first example. So for median, I have to list them in order. So from the smallest first. Smallest is 1175. Okay. And then 1181, 1195, 1275, 1295, and then 13, 1350, 15 dollars, $15, 15, 15, 1520, 1520, 1520, and then 16. Okay, so how many numbers should I have right here? 13, right? So if I did it correctly, I should have 13 numbers. Make sure you do this count because otherwise your whole median is going to be wrong if you miss one of the numbers. So now to find the middle, if there's 13 numbers, where's the middle? After the 6. Yeah, so you can do that and then count 1, 2, 3, 4, 5, 6. That means my middle is right here. Or do this 1, 13, 2, 12, 3, 11, 4, 10, 5, dot. And so where did they meet? Right here. This is the middle. So your median is 1350. Okay. All right. Let's just say if I took out one number, I took out the neuter my median would be between 13 and 1350, which would give me 1325. Right. Okay. So if there's an even number of data, you take the average of the middle two. Okay. Mode. Okay. Mode is the easiest one. Which number appeared the most? Sorry? 1520. That's it. So no rearranging, no adding. It's just looking at the data and saying which one appeared the most. So 3 provinces. 1, 2, and 3. So these 3 provinces. Okay. So suppose the province of New Brunswick introduced a housing subsidy for all people. The cost of living in New Brunswick dropped tremendously, meaning minimum wage is now $6. Okay, so New Brunswick minimum wage, we don't need it at $11.75 anymore because we're subsidizing it. So now it's just $6. How would this affect the mean wage in Canada? So instead of this one right here, instead of this, it's now 6. So what is it gonna do to the average? Yeah, Jasmine? Day 1. Bye-bye. Yeah. So if this is changed to 6, what would it do to the average? People are avoiding my eye contact. Pedro? It will lower, right? Because it pulled it out. So it will lower the mean. Okay. Okay. If it lowers it, is it still a good representation? If not, what is a better representation then? Okay. If this is changed to 6, for example, it's going to make this average maybe like around $13 only. Oh, okay. Thank you. Wow, that's a quick calculation. All right. Which would be a better representation then? The median, right? So the median, if you make a one change right here, so let's say, see this one? Even if you change this to 6, your median is still the 1350 because no matter what, that was still the lowest. And then when you move, this was still the middle. So, the median is a better representation because it doesn't change. Median doesn't change the answer. Okay. What will you consider New Brunswick's new data point as? Yeah. Outlier. Remember we talked about this when we did graphs? Outlier. So, like, let's say when you do your graph, all of the points line up to a line of best fit, and then you have a point that's out in space. So that's an outlier. Okay, so mean, median, and mode sounds easy. Pretty straightforward. Good. Okay, box plot. This is the new thing that you guys need to know. Okay. In previous grades, you have explored many different ways to display data once you collect it. My 6-year-old is doing tally marks right now. Okay, in grade 1. So I know you guys have been doing all this. So let me just remind us what these look like. So let me go to Google. Okay, so tally charts. Images. Okay, so this is what a tally chart looked like. Remember this? Back in the good old days, grade 1. You guys did this. Jelly bean flavors. What was people's favorite jelly bean flavor? Apparently it's cherry. Okay. Stem and leaf plot. I think you guys did it in like grade 3. Okay, I never understood the stem and leaf plot. It seems very annoying to me. Okay, so for example, this one, 15 and 16, you had to do it like with a stem of 1, and then the leaf was 5 and 6. 21, it would be 2, and then the 1, the 3, the 3, the 6, and the 6. You have to break up a number into 2 different parts with the stem and the leaf. Okay. The good thing with this is you can clearly see most of the numbers is in the 20s. Basically, that was the whole purpose of a stem and leaf plot. Yeah, but then I'm looking at this, I'm like, I could tell from here. Okay, so that was what a stem and leaf plot is. Circle graph. What's another name for a circle graph? Yeah, pie chart, pie graph, whatever you want to call it. Looks like a pie. Okay. People's favorite color. Most people chose blue. Okay. Pictograph. Pictograph. You guys learned this in, I think, grade 2. Pictograph. Where you have smiley face and pizzas. Okay. So, for example, this right here, a pictograph is is where you have a lot of data, but you want to fit it in a small chart. So then you use these little pictures to represent 4 children, for example. So then for people who take bus, it's 1, 2, 3, 4, 5, 6, 7. So 28 people take bus. 16 people take cars. 24 people walk, and 12 people ride the bike. Okay, so a pictograph helps you to use a picture to represent more than just one. That's what it's mostly used for. And then lastly, we did line graphs in grade 9. Actually, no. No. You did line graphs in grade 6. Okay, where you connected the dot, looks like this, something like that. And then in grade 9, what did we learn? Line of best fit graphs, which are like this. Oh, you did? Well, now you tell me? After I taught you guys this for like 2 months, you guys tell me you learned it in grade 7? Okay, so, and then today we are going to learn box plot. Yep, looks something like this. Okay, and we'll tell you guys how to draw these box plot. There's different names for it. There's this, we call it box plot. We call it whisker plot. Okay, you can see it's the same thing. We call it the box and whisker plot. Okay, it sounds so fancy when you call it whisker. Hey, can you draw me a whisker plot? It sounds so much fancier, doesn't it? Okay, so let's see, how do we draw it? Oh, and we also call it a 50% box plot. Same thing. Okay, so a way to display large data set is by using this box plot. It is designed to display a summary of data rather than each individual scores, and to visually show patterns in the data. They can also be used to quickly and visually compare two data sets. Okay, so it shows the middle value, the median. It displays the extreme value, so the maximum and the minimum. It gives the hinges, so value of each quarter. Okay, and so let's say how we construct it. So let's say you're given these data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers right here. So the first step is you have to write them in order from smallest to greatest, just like how we do with median. Now we find a median. So just like what we were saying, median is the middle number. So that 1, 10, 2, 9, 3, 8, 4, 6, 5, 5. So my median is between 34 and 36. Obviously, we know it's 35. Did I count it wrong? Oh, this is not in order. This is in order. Okay. This is in order. That. Okay. Okay, so right here, we can tell it's obviously 31. Let's say the numbers aren't as nice, then you would do 29 plus 33 divided by 2, and you get the 31. Okay, so that's my median. That's my first number. That's my Q2. The 31 is my Q2. Find the median of the first half of the data set. So from this part, so to the left of your Q2, okay, so that means I'm going to count the 29. Okay, so 24, 29, 27, 28. So the median in the first half of the numbers is going to be 28. This 28, I have two names for it, either Q1 or lower quartile. Okay, make sure you're paying attention, because on Wednesday when you do the assignment, you'll need to be doing this. Okay, and then you do the same thing for the upper half of your data. So since my median is 31, I'm using the numbers to the right of it. So I include 33, 37, 34, 36, and so my median in my upper half, upper quartile, is 34. This is called my Q3, okay, aka upper quartile. So my median is Q2, lower quartile is Q1, upper quartile is Q3. Okay, and then you also have your minimum. What's the lowest number? 24. And your maximum, which is 37. Okay, so altogether, how many numbers do I have? 5. Yeah, that's right. So when you draw your box plot, that's exactly what you draw. Your lowest, your highest, your Q1, Q2, and Q3. And then you draw a box. Okay? The fact that it's called a box plot, I better see a box. Okay? I've seen people draw me lines. Alright? Make sure if it's called the box plot, I see a box right here with like a 2-section box. And then you connect it like this. Very important is you have to have a scale on the bottom. A lot of people forget that scale and then just give me something that looks like this. And I'm thinking, numbers? Okay, so make sure you do have a scale and your box plot is according to scale. Don't just throw in numbers. It has to have a scale. Okay. So what's good about this? Well, each of these sections is 25%. Okay, so 25% of the data that's why it's called quartiles. Quartile, quarter, whoa. Okay, so each of these sections represents 20% of the data. So what percent of the ball bounces are 28 inches or higher? 75%, that's right. So 28 or higher, 25, 25, 25. So 75% of the ball is higher. What percent of the data is between the median and the upper quartile? 25%. Between median and upper quartile, 25%. Right. So looking at this, it's not as obvious, but which section does it look like it's the biggest? Okay, which section looks like it's the biggest here? Okay, and it looks like this section is the biggest. Okay, which section looks like it's the smallest? It's actually pretty even. Okay, so I'll ask that again in a better box. This one, not so good. Okay, so let's try. Okay, last example. This one right here. So let's try to draw it ourselves now. The following shows the cost of a new smartphone at different outlets. This is definitely not an iPhone, more like a Samsung. Huh? Not even. Okay. Okay, so let's so what's my very first step? Sorry? Order it, yes. Write these 10 2, 4, 6, 8, 12, 10. No, 14. 6, 12. Sorry. Let's write these 12 numbers in order from smallest to greatest. So smallest, 500, 560, 635, 650. Make sure when you do this, use pencil, so that because if you miss a number, you're not crossing out everything. 690. I'm just using a pen because it shows up better on the projector. 700, 730, 750, 800, 875, 900, and 999. Okay, there you go. We have them in order. So, Brianna, what's my next step after I arrange them? Okay, sure, we can do that. So this is my minimum. Then we have our maximum. That's good. So that gives us 2 points already. Easy point. Okay. Next. Antonia? Perfect. Find the median. Okay, move it with your finger. That. So it's between here. So 700 plus 730 divided by 2. What's the number in between? 715. Good. What is this number called? Or Q what? Q2. Good job. Okay. Okay, I have 3 numbers now. I need 2 more numbers. Lower part. Good. So do I use this 700? Yes. Okay. So this is. So it's the number in between here. So 635 plus 650 divided by 2. And we get 635 plus 650 divided by 2. We get 642.50. Whoops. Okay. What is this called? Or lower quartile. Good. Sorry? Okay. And the last number, I need 1 more number. I need 5 numbers in total. It's the upper quartile. Good. So this is. So it's between 800 and 875. So what do we call this? Or upper quartile, right? 800 plus 875 divide. Oh, by the way, one more thing. When you do this, make sure. This is a silly mistake that I see a lot of people do. They do 800 plus 875 divided by 2. What's wrong with this? Brianna? Yeah, the calculator would do the division first and then add it to 800. So what you have to do is add the numerator, press equal, and then divide it by 2. Okay, this is a silly mistake that a lot of people do. So make sure you add the numerator, equal, and then divide it by 2 on your calculator. So you get 837.50. Otherwise, you're going to get like 1,000 something. And this is called your upper quartile. Okay, so yay, we have our 5 numbers. So we can draw the box plot. What's the very first thing I need? Scale. Good job, you guys were paying attention. Okay, I know my minimum is 500. My maximum 999, so 1,000. Okay, do not put 999. Okay, remember a scale is not just like when we did scale for our graphs. We don't just put those numbers on. We have to have a scale. So go by 100, I guess. So 5, 6, 7, 10. 6, 7, 8, 9, 10. Okay, something like that. This is a little too wide, but so maybe I'll put it like this. Okay. Yeah, so remember each section, it should be the same width because otherwise your box plot will be biased, right? Especially since we're doing these box plot by visualizing it. So you need a equal scale. Okay, so 500 minimum. And when I draw my box plot, I'm not drawing on the scale. I'm drawing above the scale. Okay, so I have my 2 dots above my scale. I'm going to draw a line for 642.50, so which is about right here. 715, so about right here. And then 837.50, which is about right here. Okay. Now, do I just draw a line right across everything? No, what do I need to see? A box. Yes. How did you know? Yeah, so I need to draw a box. I need a box. Okay, I see the box. And now to connect the box with the maximum and minimum, I draw that extended line. And there we go. We created a box plot. Yay. Okay, so now visualizing it. Where is okay. Let me see. How can I ask this? Okay. What percent of phones are higher than $837.50? Sorry? Yeah, not ish, but 25%. 25% of the phones are $837.50 or more. Okay. What percent of the phones are between 642 and 837? 50%. So 50% of the phone is between 642 and 837. Okay. What's the median cost of the phone? Median cost of the phone. 715. Right, your median. It's right here. What was the maximum cost of a phone? $999. Okay, almost 1,000. Right, if you're just basing it off a box plot. Okay. Now this is a tricky question. Most of the phone are in which quartile? Most of the cost is in which quartile? Is it between the minimum and Q1, or Q1 to Q2, or Q2 to Q3, or Q3 to max? Most of the phone prices fall in which quartile? Sorry? This is a tricky question. So I see that a lot of people are saying either this one or this one. Who says most of the phone prices are between Q1 and Q2? Who says most of the phone prices are between Q2 and Q3? Well, I only have one student in the whole class. See how brave you are? Only you voted. Let me ask again. Are most of the phone prices, is it between your lower quartile and median? Or is it between your median and upper quartile? Right. Upper and max. Okay. So who says most of the phone prices are between here? Most of the phone prices are between here. Most of the phone prices are between here. Most of the phone prices are between here. Okay, wow, we have everybody saying each. So take a look at the original data. Okay, between 500 and 642, you have 3 numbers here. Between this, you have 3 numbers here. Between this, you have 3 numbers here. Between this, you have 3 numbers here. So what does that mean? It's all the same. That's why it's called a quartile. Yes, it was a tricky question. I was trying to see if you guys understood what a quartile means. Each of these sections is 25%. So 25% of the data falls in here, 25% of the data falls in here, 25% of the data falls in here, 25% of the data falls in here. So when I asked you that question, everybody who raised up their hand was correct. All right. It's but for those who didn't participate, you got it wrong for sure. All right, so make sure on the test, don't leave any questions blank. Participate. Okay, so that's what quartile means. 25%, 25%, 25%, 25%. So each of these sections are 25%. All right. On EQAO, sometimes they use Q1, sometimes they call lower quartile. So that's why I want to emphasize the different names for this. Okay, so that's the lesson. I took longer than usual today. Okay, make sure you try these questions right here and answer the questions with it. Okay, there are quite a few, but I did also include the answer key. Okay, so make sure you try it. You're gonna see these questions on Wednesday on your assignment. Okay, so try these. This is the homework. You have about 20 minutes now to get started on the homework. It doesn't take long. Make sure you do the box plot questions because that's the totally new thing for you guys. Yeah. Okay.